Let me tell you a quick story. A junior developer sits in an interview. Then the interviewer asks one question. Can you explain polymorphism? The room goes quiet. Not because the developer is bad, but because most people were never taught why polymorphism actually matters. Here's the interesting part. If you understand this video, you'll never freeze on that question. By the end, you'll have two things: a clear mental model and a sentence you can use in any interview. No textbook definitions, no syntax dump. Just one idea, the idea that makes object-oriented programming finally click. In the last video, we talked about inheritance. And at first, inheritance feels amazing. You reuse code, you model real-world relationships. Everything looks clean and organized. You ship it, you're proud of it. Then reality shows up. The requirements change. Suddenly changing one thing breaks three others. Adding a new feature feels risky. Your clean hierarchy starts fighting you. Inheritance gave you structure. But structure alone doesn't handle change. That gap, the gap between structure and change, is exactly what polymorphism fills. If you remember only one thing from this video, make it this: different objects, same interface, different behavior. That's polymorphism. Not lots of classes, not fancy inheritance trees. Polymorphism is about behavior. Here's the interview-ready version. Polymorphism is when different types share the same interface, so the caller can use them interchangeably without changing its own code. If you can treat multiple things the same way, through the same call, the same message, and they respond differently, you've unlocked the real power of object-oriented programming. Let's ground this in something familiar. Think about a remote control. There's one button, power. You press it. If it's a TV, the screen turns on. If it's a speaker, music starts playing. If it's an air conditioner, the room cools down. Same action, different result. Here's the key insight most people miss. You don't care how each device works internally. You care that it responds correctly when you press power. That mindset, same request, different behavior, and I don't need to know how, is polymorphism. This is where your thinking as a developer levels up. Instead of writing code that depends on specific concrete things, you write code that depends on a promise. The promise sounds like this: if you can perform this action, I don't care how you do it. The caller doesn't ask, are you a credit card? Are you PayPal? The caller just says, process the payment. And the moment you design like this, a lot of complexity quietly disappears. Now watch closely. This is where most explanations stop too early. Imagine your checkout logic without polymorphism. Notice what checkout is doing. It isn't just processing a payment, it's deciding what kind of payment it has. In the inheritance video, we already defined this promise. Every payment method agreed to behave this way. This is where polymorphism actually happens. Checkout no longer asks what it's using. It only asks what it can do. Same call, same code, different behavior, and checkout never changes again. That decision, What kind of payment is this? Used to live in checkout. Credit card? Do one thing. PayPal? Do another. Apple Pay? Something else. Every new payment method means editing that same decision logic again. Here's the question that reveals everything. When a new behavior appears, which part of your system has to change? If the answer is always that same decision block, you don't have polymorphism yet. Now let's put that into a real situation you will face. You're building checkout for a startup. Version 1 supports credit cards. Great. You ship. 2 months later, the business says, we need PayPal. Then, we're expanding. Add Apple Pay. Then, this market needs a different provider. Without polymorphism, the same core logic keeps getting opened up. Conditions grow, logic spreads. Every change feels dangerous. This is how code bases rot, even when the developers are smart. With polymorphism, every payment method follows the same promise. I can process a payment. Checkout doesn't care which one it's using. It just calls the same behavior. Adding a new payment method becomes create a new implementation, plug it in, and leave checkout alone. That's not just elegance. That's how real systems stay alive over years, not just over sprints. This is where a famous principle quietly shows up. Open for extension. Closed for modification. In plain language, you can add new behavior without touching code that already works. Polymorphism makes this practical. Your core flow, like checkout, stays closed to change. New behaviors are added around it, not inside it. Once you see this, you'll immediately notice when a system is designed against change. When every new feature forces you to crack open the same file again. Now let's kill a common misconception. Polymorphism is not inheritance. It's not method overriding. It's not interfaces by themselves. Those are tools. They enable polymorphism, but they are not the goal. Polymorphism is the result, the ability to swap behavior without changing the code that uses it. Inheritance defines who can be substituted. Polymorphism is when the system actually uses that substitution. Different languages achieve this in different ways, but the idea never changes. If adding a new behavior forces you to rewrite the logic that decides what to call, you don't have polymorphism. You have a fragile design pretending to be flexible. Object-oriented programming isn't really about classes. It's not about diagrams. It's not about clever hierarchies. It's about designing software that doesn't fight change. Once you truly understand polymorphism, inheritance alone starts to feel incomplete. You stop obsessing over trees of types and you start caring about how easily behavior can evolve. So here's the takeaway. Same interface, different behavior. No caller changes. That's polymorphism. If someone asks you in an interview, what is polymorphism? You can say, polymorphism is when different types share the same interface. So the caller can treat them the same while each one runs its own behavior. And before you go, think about your own code. Where would adding a new behavior force you to touch too many places? That's where polymorphism will change everything. With this, we've completed the core ideas of object oriented programming, not as definitions, but as working design tools. I'll see you in the next one.